If we've completed setting up our switch, then we've created the VLANs that we need. We've assigned the VLANs to the ports, and we created our trunk links back to either other switches or up to the router. We still have the issue, though. We have to configure the router to be able to route between the two VLANs. It's one wire. I'm going to have some traffic going up the wire, potentially hairpinning through the router and coming back down to the next side. That would be that trunk configuration on the router. We call that a router on a stick or a one-armed router because it's one physical wire that's going to be broken into multiple logical wires, if you will, virtual wires. Sub-interfaces is what we call it. We'll take a look at the router and how to set that up. We have R2 right here, which is going to be our router on a stick. What we need to do with R2 is we need to be able to carry the VLAN, the HR VLAN or the VLAN 50 traffic up to the router when it needs to leave. So I have to have again, if this is the 50 network, I need to have a router interface. It's 192.168.50. And again, I like to use the first address in the space as my router interface. So I'm going to have a router interface of 192.168.1.50. It's the same wire that's going up because this is now configured as a trunk for the 30 network. So for the 30 network, if one of these devices wants to communicate outside the local network, then I have to be able to carry that blue traffic up the same wire. That also means I'm going to have an IP subnet for the 30 network, so I'm going to have another interface or another routable component that's 168.30.1. So how do I get two different IP addresses on this physical interface? I'm going to create logical sub-interfaces. So I actually have my physical interface FA0/0. What I want to do is create logical sub-interfaces by putting a dot here, decimal point, but a dot. And when I do interface FA0/0 dot something, so dot 50 or dot 30, I will create the logical sub-interface. I can then configure each one of those with its own IP address. So if I look at my router, let's see, needs to be squashed down a little bit so you can see it there. There we go. If I look at my router and I do enable Cisco show IP int brief, all I have is fast Ethernet 00, which does have an IP address. I have fast Ethernet 01 and serial 00. Again, serial 01 is not being used in this particular diagram. There was another router at one time. I should probably remove that IP address because it's not necessary. But if I put an IP address on an unused interface, really no harm, no foul. It won't be used. It's just an address that I potentially might have issues with somewhere else. So again, I'm going to leave it there for now. But I do want to create my sub-interfaces to create my router on a stick off of the physical fast Ethernet 00 interface. So one of the first things I'm going to do here is I'm going to remove the IP address on the physical interface. I don't care for it to be there. I'm going to create two logical sub-interfaces, so the physical interface doesn't need an address. So conft interface FA0/0. How do I get rid of an address? I use the command IP address to put it on, so I would do no IP address to remove it. Do show IP int brief. Shows me that fast Ethernet 00 actually has no IP address. It's still here. It's still up and up, but it doesn't have an address anymore. That's all right. We're going to put one on here in a minute. So what I want to do is I'm going to create interface FA0/0 dot 30. My protocol just changed state to up. If I do show IP int brief now, you can actually see that I have just created an interface called FA0/0 dot 30. I just created that sub-interface by using the interface fast Ethernet 0/0 dot 30 command. I can now give this interface an IP address 192.168.30.1, which will be my default gateway. Going to use a mask associated with it again. Love the help functionality. So we need to create that encapsulation for .1Q, which is our VLAN infrastructure. So within that sub-interface, we'll do encapsulation. encapsulation.1q, which is the protocol that we're using. And then we need to specify the VLAN number here, which is VLAN 30. And that should take care of it for us. Do show run. And we can see under interface FA0/30 that we have our encapsulation.1q30, but we don't have an address. That was the error message that we threw. We can't give a subinterface an IP address until we assign it to a VLAN. So we'll go back, take a look. Now I do my IP address, 192.168.30.1. No issues whatsoever. I'm going to save that configuration because I don't want to lose it. I'm going to do show run. And if I look back at my FA0/0.30 interface right here, we can see that the address is set. I want to point out to you that this is the subinterface number, not the VLAN number. This is the subnet number, not the VLAN number. This is the VLAN number. It sounded a little ridiculous when I said it, but they're all the same value, 30. But the 30 means something different on each line. The subinterface is 30. It doesn't have to be the VLAN. I could have subinterface 1 if I wanted to, subinterface 2, subinterface 3 with a VLAN number. Just because I created the VLAN as 30 doesn't mean the IP address has to be in the 30 subnet. VLAN 30 could be on the 113 subnet if you wanted it to. Typically when we do demos, we use them all the same number because it makes it very easy for us. So that's my .30 interface, which should work just fine. I do also have to deal with the other subinterface to be able to route through. So we would go into, I'll save got it here, do interface FA0/0.50. Interface FA0/50, 0/50 creates the 50 subinterface. It is now up. I would want to do my encapsulation.1q 50 first and then give it an IP address. IP address 192.168.50.1, 255.255.255.0. Save that, do right. Show IP int brief. Shows us that we now do have our two subinterfaces configured. They have IP addresses, they're up and up, and they should be doing the work that we need them to right now. So we should be able to ping from PC to PC, from PC to server, and everything should work just fine for me. I can actually do my show interfaces, show VLAN, show interface VLAN trunk. So show VLANs here will actually show me, show VLANs, show. Apparently that command is not implemented on this particular router, but that's okay. Show interface, show IP interface. Well, we did our show interface, IP interface brief. Again, shows me what we have configured in their status, up or down. We should verify their functionality to see if they actually work. How would I do that? Let me jump into my PC. PC2, for my command prompt, let me check to make sure it has an IP config. It does, 30.100. So the server was 30.200, so I should be able to ping 192.168.30.200. That was successful. I should be able to ping 30.1, which is my router interface. Successful. I should by rights be able to ping 50.1, which I can. 50.100 would have been the PC on the other side. And I had to do an ARP request, which is why it timed out, but it works just fine. So what's happening when I ping 192.168.50.100 from PC2? What's happening there? Oops. Sorry, that was off your screen a little bit there. Apologize for that. What happens here is from PC2 to 50.100, so from 30.100 to the 50.100, the packet goes out PC2, up to the router, the router realizes it's on another network, takes the MAC address off, does its thing, puts a new MAC address on, that of the PC, sends it back down the same physical wire and out to the PC to communicate. So that's the whole concept, the whole idea behind a trunk and how that actually works for me. That is router on a stick, also known as inter-VLAN routing.